Okay, so now we're moving into the to lecture 3, Introduction to ANSYS Design Modeler. So here we can see the agenda for lecture 3, and we're going to cover how ANSYS Design Modeler fits into the pre-processing workflow for an ANSYS simulation. We'll talk about what ANSYS Design Modeler is and how to launch Design Modeler. And then we'll talk about the interface, or the GUI, Graphical User Interface, and some of the toolbars that support the GUI for Design Modeler. Okay, so here we can see a slide which demonstrates the pre-processing workflow and how the geometry steps fit into this workflow. So at the top of the chevrons at the top, we can see the process from left to right of importing or creating the geometry, performing some geometry operations if needed, moving to meshing and solving. Typically, pre-processing refers to the early part of the simulation workflow, and that is the geometry and also up to the meshing steps of the overall process, as opposed to the operations after the solver, which are termed post-processing. Okay, so you can see here with geometry creation and import and geometry operations and the pink region underneath, this is the area that's represented by Design Modeler. Now, it's not necessary that we create geometry or import the geometry. We can of course do both. We can import a geometry and do some additional geometry creation. An example of that would be if we were to import a solid, the metal part of a component, and we need to extract the fluid region in order to perform an FSI or a fluids type calculation. So what we can do is import the solid and use the tools in the geometry engine to extract the fluid region, and then progress into the calculation with the fluid region. Then we may also need to perform some geometry operations beyond that, such as some Boolean operations, which if you use CAD systems you'll be familiar with some of those operations like splitting. And then we also may need some geometry operations in order to clean up and prepare the geometry for simulation. It's typical that any original CAD that's brought into Design Modeler is actually of the solid manufacturable parts, rather than clean surfaces ready for simulation. So it's typical that users would have to go through some geometry operations in order to prepare the model for a simulation. And it's important to understand that there are key differences between manufacturable CAD and CAD for simulation. Okay, we also place a note there that that Design Modeler uses the Parasolid kernel, and this is because Design Modeler has been developed from a Unigraphics toolkit, and of course that also uses the Parasolid kernel. So the Parasolid is the method by which all of the geometric operations are performed. Okay, so moving on now to explain a little bit about what Design Modeler actually is. Well, we mentioned it uses the Parasolid kernel because it's based on the Unigraphics toolkit, and it also acts as a parametric solid modeler. We can see an example here on the right of generating a sketch and then moving directly from the sketch to the 3D model. So the example there would be that we generate it on a plane and then extrude it or pad it into a 3D model. So we can use Design Modeler to quickly and using the GUI intuitively create 2D sketches and 3D models to prepare it for analysis. And I mentioned we can do 2D sketching or 3D modeling. If we were doing a 2D analysis, of course we would remain in 2D as far as sketching. But if we wanted to do a 3D analysis, we can take a 2D sketch and move that into the third dimension in order to create a 3D model as well. And it also comes along with some dedicated tools for not just import and clean up on import, but also clean up after import as well. Typically you can have problems with geometry that's imported. It can have gaps or overlaps or be disconnected, and there are tools inside Design Modeler to treat all of these types of geometries.